How you guys doing today? Doing good? So, yeah, let's do another review today so we can put it ready for later. So maybe you can try this one. Okay, in about 1 minute. This one. About 30 seconds. What about the green hour reaction? Okay, so here's the thing. So today, most likely, I'm gonna tell you the simple trick you can do, so you can actually get the right product over there. So if you have this type of thing, just separate them as two. So this is your R group, right? And this is your, magnesium bromide here. So just separate them here, and just put this one on the carbon right below the oxygen in the carbonyl group over here. Okay, and then remove the double bond and put the hydrogen on here. Okay, so if you do that, this one. Okay, so just attach this one to here, and double bond is gone, and put the hydrogen on the oxygen. So this is a hydrogen group. That's it. This is a trick you can. Screen reaction. Place the R, remove the double bond, and put the hydrogen on the oxygen. Okay. That's the trick. So let's do one more. How about we do it for ketone? This was aldehyde. So we do ketone. Okay. This one. This is a ketone now. Do the same thing. Do the same thing. What happens? Do the same thing. Okay, so yeah, basically this is our group here. We'll go to here, this carbon and the carbonyl groups. Okay. And just hydrogen. That's it, right? Okay, it's perfect. So make sure if this is what, maybe other group over here, it could have been just that. Okay, whatever the R, just attach it here, and remove the double bond, put the hydrogen there. That's it. All right. So how about we have ester compound? Do the same thing here. Okay, let's try this one real quick. So now we tried aldehyde, now ketone is the ester. Let's see what's the difference. It's almost same, it's slightly different for this one. Okay, about 30 seconds. Okay, so here's the thing. If you have a carbonyl group with some ether, it makes the ester group here. Same thing, separate them here. Okay, this is all, the methyl group is your R here. And what you can do, you can just try to remove or this one, okay, and put 2R and hydrogen. Okay. If you have an ester group, just remove that ether group away, and then put this one twice. Twice, and put the hydrogen dots. Remove the double group. That's the trick. If it's ester group, remove the ether group part, remove the double bond, same things, hydrogen, but for this R, it's twice. So if it was ether group instead, okay, could have been just like this, okay, same thing, but just all right, let's try this one. So you have a secondary alcohol. You're gonna treat with the phosphoric chloride with the pyridine solution. Let's try this real quick. About 1 minute. Okay, 30 seconds. Okay, for this one, this is quite simple. So just briefly explain, this will grab to this one to leave one of the chlorine here, and one of the implied hydrogen will pick up by nitrogen and pyridine, so it goes to here. So what you just need to do, and then once they have a better leaving group, they left, so just remove this one. That's all you need to do, okay? So where you have the hydroxy group, just remove it and put the double bond when the carbons are not right next to it. So it doesn't matter if you throw it here, it will be the same thing. Makes sense, right? All right, let's try this one. This one. Oh, it's a Martin periodinate. And this is just the solvent, organic solvent. Okay, about 30 seconds. There's a very simple trick that I'll tell you. Okay, so whenever you look at this one with the Martin periodinate, you just need to remove the hydrogen, just double bond there. That's it. Okay, this is the same for primary alcohol and also secondary alcohol. So if you had instead of this primary alcohol, you had a secondary alcohol, same. Just remove the hydrogen. That's it. That's the trick you can just. Okay? Makes sense, right? Just remove the hydrogen. All right, let's try. So this is only for primary alcohol. I'm gonna treat with the chromium trioxide with the acidic condition and some the acetone base for medium. about 1 minute. This is only for primary case. Okay, so here's the thing. You have this primary alcohol here, right? And this is a carbon right next to your hydroxy group. And just put double. That's it. So you will have a carboxylic acid compound, right? Carboxylic group. Okay, if it's primary alcohol, when you treat with the chromium trioxide, just put the carbon right next to the hydrogen group with the double bond with oxygen. So it will become carboxylic acid. Okay. Pretty easy, right? It's just a simple trick you can do. The thing is you have to memorize this one. All right. Okay. So let's try this one. We're gonna treat with the diorganol copper. Some acidic conditions. Okay. Let's try to do. Okay, about 1 minute. Okay, so in here, when you look at the diorganol of copper here, there's the same R twice, which is in here. It's a methyl group over here, and then normally they were tagged here in carbonyl groups, but the thing is you have the double bond right next to it, one another. So this will show you some kind of a conjugate region there. Okay, so there will be some exception. So whenever you do diorganol copper, only one R attached to it, not two. Even though there are two, only one R attached to here because of the copper. But anyway, so the one R goes not here, but here because of this double bond here, and this will be conjugate. Double bond, single bond, double bond. Conjugate, right? So you're gonna add the one R, not two, okay? There are two, right? But just take one R, attach the end of the conjugate region here, and just remove the double bond. That's the trick, okay? So you have a conjugate region over here, right? And just the end, the last part of your double bond, which is here, add just one R from two here, remove the, because there will be hydrogen attached here. Once they go move, and this will be, this carbon will catch the hydrogen, that's why. But the trick is, so remove this one, put the R there at the end. That's the trick. Okay. Makes sense, right? All right, let's try this one, okay? We're gonna treat with the methylene triphenyl phosphorane, okay, which is this one. Sometimes you can do this one. It doesn't matter, but they're the same thing. So 20 seconds. Okay, so then what happens here is that this one is positive, negative, right? So this will make some like a cyclic intermediate form, and eventually they pick up the oxygen with the double bond. This one will be attached to here. That's what happens. So if you look at this one here, you only need to look at the one with the carbon, which is CH2. Okay, and this oxygen will be picked up by this one. So remove that oxygen, replace that with the CH2. CH2. That's the answer. So whenever you treat with this methylene triphenyl phosphorine, you just don't care about this one. This will pick up the oxygen here, and they'll replace that with this, the carbon groups with CH2. That's it. Okay. So if it was a CH3, which is CHCH3. That's it. So only look at the carbon group, remove the oxygen, just put that right on. That's it. Makes sense, right? All right, let's go. Let me see. Okay, this one. There's a 2 right there. That's the hint. That's the key point. Okay, so here's the thing. So one methylene comes and bound to here. Obviously, this is the target, right? Here, and this electron goes there and pick up the one hydrogen. Okay, and then another one attack the same carbon here as well, and then this will take another hydrogen, make it water, so they leave. Okay, so these two are attached here, but the hydrogen will pick up by water next time, every steps. So the trick is just remove the carbonyl group, because they will be leave as a water when they pick up the 2 hydrogen eventually. But just put this methyl group without 1 hydrogen, because the hydrogen will be picked up by water. They form acetone. Okay, so they form 2 ether on the same carbon. So the trick is the remove the oxygen, okay, and then remove the hydrogen and attach that same carbon twice. So it's acetate formation. Makes sense, right? Let's try to do this one. We're gonna trip with the hydrogen. Basic condition. Yeah, about 1 minute. Okay, so here's the thing. Hydrogen, it just looks like very similar to primary amine. Okay, because this is 2 hydrogen with 1 R type of bonding here. So they form like imine first, like we did later anyway. And then when they imine pick up lose that hydrogen, the electron move to this carbon as a negative charge, but twice. So they pick up the 2 hydrogen there. And when they do it, this imine to nitrogen will leave. So this is what happened. So only thing you have to do here, this one, right? So with hydrogen, let's remove this one. Because it will be replaced by 2 hydrogen. So there's always 1 hydrogen over there, right? Okay. Here like this, okay. And this will be gone, and 2 hydrogen will be added. So just the method. But the hydrogen will be implied there. So if there's a carbonyl group with the hydrogen, just remove the oxygen. That's the truth. Makes sense, right? Okay. Alright, let's move on to, okay, this is what we mean by, we're gonna treat this one with the primary amine. Okay, about 30 seconds. Okay, so here's the thing. So if you look at this one over here, this is what it looks like. So it's a primary amine, okay, here. So when you attach to here, this will still one of the hydrogen here, so become hydroxy group. Then when they make the double bond, they're gonna pick another hydrogen from water, so they become like a water group, which is really good leaving group. So they leave, and that time they're gonna attach with another bond, which will be double bond. So they're attached to here. So one will be gone, and later this will be picked up by the other water. So this will become, so just remove, this will be water that will leave, but this will keep the double bond here. So you can just do this one. So this is our imine formation. Okay, so just remove the oxygen here, okay? Remove the oxygen, and remove these 2 hydrogen, one picked up by oxygen, one picked up by another water, and this goes to right there. Just replacing that oxygen with the one primary, the methyl group right here. Okay? That's the trick. Can I move on? Okay, how about we have a secondary amine? Okay, so we have a secondary amine. What if we have a secondary amine? So we're gonna form an amine now. Okay? Secondary amine, what happens? We form the enamine. Okay, so in here it's almost same as what we did for like imine, but here we only have 1 hydrogen here. So we have another hydrogen somewhere at the end. This is actually coming from. So what happens to here is just try to remove the hydrogen also, same, okay? And remove the one double bond here, one bond and double bond here. And this will be gone as water as well at this time too. And then you put the There's two secondary amine group over here, and this will be picked up now instead of that other hydrogen source, so it goes to the form the double bond. This is what we call this the in-amine group together, so it'll be enamine. We call this enamine formation. So if you have a secondary amine coming in to do something with the ketone, they actually going to form the enamine instead because of their hydrogen will be actually coming from the other next neighboring carbons, adjacent carbon hydrogen. Okay. So that's these. Makes sense, right? All right. How about we have a benzaldehyde, and we're gonna treat it with the okay. So this is also kind of a good example for the chapter 19 because this will show you H and Y addition here. So what it does is when they go to the Y, okay, they replace the double bond with the hydrogen. So this is like a hydrogen that Y addition. This is so if you think about it, it's just that. So you don't have to show the hydrogen, but this hydrogen goes. So you're gonna just see cyanide group. So this is a very good example. So if you have like a X Y form, Y is this one, right? And then add it to right there. But the hydrogen goes to the carbonyl group oxygen, so it'll be hydroxy groups. Okay. So this is a quite good example. There's some exception is water hydration, but it works well on the formaldehyde. So if that case, they can form germinal compound. The two hydrogen group on the same carbon. So we call it zamenodiol or zemdiol. That's what we did before. All right, so that's all I have right now today. Do you wanna do a little more? Like a more practice problem, maybe we can try. Because this is all I have today, but maybe. Okay, maybe you can try this one. Think about what we just did for diagonal copper. Addition here. Because of the see those two positions, our better position is unsaturated. So think about not here, but this whole thing. So where you're gonna add your R groups? Just one, not two, even though there's two. Right? So because of this double bond here, right? So it'll be conjugate. So I'm not gonna put the one methyl group here, but here. This is the end of the conjugate orbitals. So I'm gonna remove the double bonds. Later they're gonna pick up the hydrogen because this carbon will become negative charge. You don't have to show the hydrogen anyway. So I'm just gonna do this. That's it. Makes sense, right? Because this is somewhat. Okay, maybe. Okay, can you guys try this one? Okay, so yeah, it's the same, right? So remove the hydrogen here, okay, and you do it twice, right? So you're gonna remove this one, just put over there. Okay. Alrighty. Let's try to do. Can you guys do this one? Okay, so yeah, same, right? So once again, remove it. Okay. Okay, let's do just a few more. Can you guys try cyclohexanone with the desmartine or iodine? Some organic solvent there. So now it's a secondary alcohol. Oh, sorry. Secondary alcohol, not the ketones. Secondary. Okay, so this is quite simple too, right? Just remove the hydrogen. Okay. You guys try. Okay, so in this case, so always just add an R to head here. This goes to negative charge, protons. All right, So, oh, wait. I think I can have one more. Oh, here we go. Oh, I almost forgot. Okay. So it makes sense, right? Though. Yeah. Almost forgot. Just one more thing, or that will be all. So if you have ester group again. Okay. So you're gonna treat with the diisophysic aluminum hydride in toluene with acidic conditions with this ester group. What happens? This is also very easy trick you can do. Okay, about 30 seconds. Almost forgot. Okay, so here's the thing. In here, it's very strong, the hydrogen addition here. So if you have an ester group, at this time, I'm also going to remove the ether group of the ester group and just gonna switch by hydrogen. That's it. So you have ester group, that ether part-like groups on the ester group, remove it and replace by hydrogen. So it'll become aldehyde. All right, so that's it for today.